We know a usual metric space is a non-empty set together with a metric defined on it, and the metric D assigns a deterministic distance between any pair of points in the non-empty set. But here the idea is something different. For that, we define distance distribution function. A distance distribution function is a non-decreasing function f defined on R plus, which satisfies f at 0, 0 and f at infinity is 1 and is left continuous. And epsilon a and epsilon 0 are the unit step functions. Epsilon a is 0 from minus infinity to a and 1 for greater than a. And similarly, epsilon 0 is defined. Another idea used in probabilistic metric space definition is a triangle function. A triangle function is a binary operation on delta plus, or it is an operation between distance distribution functions. And that should be commutative, associative, and non-decreasing in each place. And epsilon 0 is considered as the identity of the triangle function. The two main examples used in our study are tau of fg. The usual product of two distance distribution functions is a triangle function. Another one is we consider a binary operation on 0, 1 tm of ab as maximum of a plus b minus 1, 0. And this operation can generate a triangle function, and that is denoted by tau tm. So these two triangle functions are used in our study. Now, what is a probabilistic metric space? In a usual metric space, we know that a non-empty set S together with a metric D defined on it, and D satisfies some conditions. Similar conditions are defined here with the modification. Here, probabilistic metric space is an order triple SF tau, where S is a non-empty set and F assigns a distance distribution function to each pair of points, or F is a function from S cross S to delta plus, and tau is a triangle function. So instead of giving a usual or a deterministic distance between any pair of points in S, we assign a distance distribution function to any pair of points in S. And that can be considered as probability that their distance between is less than x at a time point t. And the conditions, formal conditions are FPP is epsilon 0, the unit step function, FPQ not equal to epsilon 0 for different points P and Q, and FPQ should be equal to FQP. And instead of a triangle inequality in usual metric space, here we consider the Menger inequality, that is FPR greater than or equal to triangle function tau of FPQ and FQR. If only third and fourth conditions are true, the space is also called pseudo probabilistic metric space. Now let me introduce what are Markov processes. Markov processes are a special kind of stochastic process. Stochastic processes are processes in which we cannot give actual deterministic value or the outcome at any time point t. But at any time point t, we can give the probability of all possible outcomes. So at each time point, the outcome is represented as a random variable, or the whole process is defined as a collection of random variables. And in Markov process, a stochastic process with an additional probability. That means the process or the outcome at a time point t depends only on the last available value and not on the previous values. So the theoretical definition is the conditional probability a less than xt less than b given xt1 equal to x1, xt2 equal to x2, etc., xtn equal to xn is equal to probability that xt lies between a and b given xtn equal to xn. So that probabilistically depends only on the last available value. And this property is also called a lack of memory property. And when the possible values of xt are finite or denumerable, the Markov process is also called a Markov chain. Then what are stationary processes? A stochastic process xt for t in t is said to be strictly stationary if the joint distribution functions of xt1 plus h, xt2 plus h, etc., xtn plus h, and xt1, xt2, etc., xtn are the same. That means the joint distributions or simply the probability distribution does not depend on the time points, but only depends on the time duration, not on the time points. In such a case, the process is also called time homogeneous or simply strictly stationary. When a Markov process or Markov chain is stationary, it is called a stationary Markov chain. Okay. These are the main two references for our study. One by Richard Moynihan and the paper titled Probabilistic Metric Spaces Induced by Markov Chains. Another one by Philip S. Marcus, titled Probabilistic Metric Spaces Constructed from Stationary Markov Chains. Now let us consider what are general birth and death processes. Let xn denote the size of the population at time n, and state space can be finite or infinite. Bi greater than 0 is considered as the probability of a single birth at state I, and di greater than 0 is the probability of a single death at a state I. And initially we assume only one death and one birth occurs at a time. So the probability from one state I to another state j can be defined formally like this, and we can construct the corresponding matrix of transition probabilities, and that is a valid transition probability matrix in the sense the sum of elements in each row is exactly 1. So this is a transition probability matrix, or this is the transition probability matrix corresponding to the general birth and death processes. Now we study how can probabilistic metric spaces induced by general birth and death processes. Let S is the state space 1, 2, 3, etc. and P is the transition matrix defined above. When the probabilities are considered as stationary or time independent, that will give a time homogeneous stationary Markov chain. For any pair of states I and j, we can define a probability like this: probability that the process reach at the state S in less than t time when the initial state is I. And this Fij will be a valid distance distribution function to any pair of states I and j. And this Fij will satisfy the conditions of distance distribution functions, that is theorem 1. Fij defined above will satisfy these conditions. Fij 0 will be 0, Fij is left continuous, Fii will be epsilon 0, the unit step function. And for two distinct states, Fij will not be epsilon 0, and it will satisfy the Menger inequality with tau as the usual product. That is our theorem 1. And theorem 2 is, with these conditions, we can prove that our state spaces together with these distance distribution functions will form a probabilistic metric space, where tau is taken as the usual product, and it does not satisfy the condition FPQ equal to FQP, and it is a probabilistic metric space with a non-symmetric distance function. And T-norm or triangle function tau is considered as the usual product. So that is our theorem 2. Next is a modification of modification of general birth and death and processes. Here, instead of considering the state space as 0, 1, 2, 3, etc., here we consider the state space as power set of the whole population. And one thing is clear, that a single number of elements in a population can represent different subsets. So in order to avoid that condition, we consider power set of the population as a state space. So here also transition probabilities can be defined from one subset to another subset of the population with these conditions and with this transition probabilities. So here also we can prove that this is a stationary Markov chain with some basic initial assumptions. So as in case 1, we can define distance distribution functions to any pair of states in the space. Here the states are represented by, or the subsets are represented by the states, and Fij of t is probability that the process reach at the state or subset Sj in less than t time when it starts at the subset Xi. So instead of I and j, here we use the subsets Si and Sj in the definition. So this also will give a proper distance distribution function to each pair of subsets Si and Sj in the power set. So that is again will give a stationary Markov chain then when the probabilities are assumed as time homogeneous. So here let S is the population, P is the transition probabilities, and X and N belongs to N is the corresponding Markov chain. Then Fij defined as in the previous just above. Then also we can prove that SF is a probabilistic metric space with a non-symmetric distance function as in case 1. And here we can prove one more result, that is theorem 4, that S1 and S to be two states for the subsets of P, we can prove this result. And the last case is? Okay, I'm concluding. Okay. In the last case, we considered the state space as the power set itself, but we consider the cardinality of symmetric difference as a metric space. So the state space will be a metro space, and we define distance distribution functions in a slightly different way. So when the state space is considered as a metro space, then also we can assign distance distribution functions. So then also it will introduce or induce a probabilistic metro space structure, and these are the main results. And these are a few references. Thank you.
Any questions from the audience side? Any questions from the audience side? Okay.
Okay, thank you.
Thank you, sir. Then the next presentation number is C23, Shweta. Shweta, are you ready?
Yes, sir.
Okay, check your audio and video, please.
Yes, am I audible?
Yes. Please share your screen.
Yes, sir. Is my screen visible, sir?
Maybe share. Just wait. Okay. Your time.
Is it visible? Hello, is it visible, sir?
Yes.
Yes, okay. I'll start. A very good morning, ladies and sorry. Yeah, a very good morning, ladies and gentlemen. My name is Shweta, and I'm presenting a study on marketing dynamics on sales of electric vehicles and SWOT analysis. So basically, in this project, what I have done is I have taken the real-time data set of electric vehicles collected in from 2019 to 2022 and have projected what will be the sales in 2030 using time series models and neural networks. And I've studied the CAGR, that is compounded annual growth rate, and including the SWOT analysis. So if you consider the electric vehicles market is a growing market, even in globally as well as in India market. If you see the Indian market, the sales have given below the graph in quarterly yearly sales. And that now due to the increase in electric vehicles in the electric market all over the world, this is a target of Indian government as told in the budget 2022. 30% of private cars, 70% of commercial vehicles, and 40% of bus and 80% of two and three wheelers should be electric by 2030. This is a target set up by the government. Now, my research question is that what would be the growth of electric vehicles by 2030, and who are the top contributors? So, I've taken the real-time electric vehicle sales from Jan 2013 to Jan 2022. So these are all the Excel sheet, and this is the graph of each. One is the two and three wheelers combined, another is bus, and another is car. I've taken two and three wheelers combined because this was the target set up by the government. That is, together there should be 80% of electric. Now I've projected the sales in 2030 and using the models Sarima, exponential smoothing, LSTM, moving average smoothing and regression, I've projected to 2030. I've seen which model gives the best result, and I've taken the accuracy and then have projected that particular model to 2030. Using the data is split into training and testing set, and the training set is used for finding out training that particular model, and then the testing set is used to find out the accuracy, and based on that accuracy I have taken that particular model to project 9 years ahead. So these are all the models used, and you can see the accuracy table. This accuracy is found out by using the testing data to predict what would be, and the prediction and the testing data is compared to find out the accuracy. So this is accuracy. So here we can see that Sarima and moving average smoothing gives the good accuracy, but there is a problem here. So I have taken Sarima for forecasting. because even though the accuracy is similar, I have taken only Sarima for forecasting. That is the reason, because when I projected 2030 both the sides, moving average it shows that after a certain period it is constant. Trends cannot be constant, and here moving average after a certain period of time it shows constant, which is contradiction. So I have not taken moving average. Moving average is good for short time period but not for longer ones. So I've taken Sarima for a better result. And using Sarima model, I have calculated the 2030 what will be the sales of electric vehicles on all the segments. I have calculated the CAGR also, and this is the CAGR formula. And after calculating the CAGR, this is the result. Like these are the percentage growth India will witness in 2030. But with this growth, the target will not be achieved, and there should be few other measures to be added. Now, finding out the factors in market. Basically, market dynamics is nothing but the factors which influence both the supply side as well as the demand side in a particular market. So here, if you see in electric vehicles market, if you see generally, if there is a demand increase, there will be supply increase also. And you can see this is electric vehicles demand, electric vehicles sales over the years. And all the dynamics involved, all the factors involved in electric vehicles include the crude oil imports. India is dependent on other countries for the crude oil. Crude oil is nothing but petrol and diesel is obtained from crude oil. So India is dependent on other countries. 86 percentage of crude oil is been imported from other countries, and India tried to produce the crude oil also, but as you see in the graph, it's only a limited because of the unavailability of the raw materials. And other on the other hand, the crude oil price is also increasing day by day, and India has to pay a hefty amount to the other countries to get the crude oil. And this is one of the factors why we are going towards electric vehicles. And charging stations, there are three types, that is private, commercial, and public charging. Private charging stations means in-house you can charge the electric vehicle, and the charge will be added to your household electricity bill. Commercial is a particular locality, they will set up a charging station used by that particular locality. And public charging stations for the public use, and you have 1640 public charging stations all over India. This is one of the factors that affects the electric vehicle demand and supply side, one of the market dynamics. And the economic conditions, if you can see that all over the world they are going towards electric vehicles, and if all the world starts producing electric vehicles and India is left behind, the countries which produces crude oil to India will double its price to sell to India. So that is one of the reason, because India cannot full depend on petrol and diesel for the fuel, because if other countries switch to electric vehicles and India is left behind, so the imported countries will charge even more amount to India to give electric vehicles to sell their crude oil. And electricity, despite India being the world's third producer of electricity, there are few problems which is faced by the in Indian citizens. If you see, this is a total electricity generation over the years, but if you see the peak demand and peak met, it is not always equal. So that means that though India is trying to produce a huge electricity, always the demand is not met, and this is one of the factors. And pricing, there is some misconception about the pricing of the fuel and electric vehicles. People think the electric vehicles are too costly to buy, but not the case. This is the price range, and I admit that electric cars are now costlier compared to the other fuel, but in upcoming years it will change also. And this is a running cost calculation of ICE versus electric vehicles of all the segments. And these all specifications are given by the government themselves, and have taken state Tamil Nadu because that is the state I am residing in. So this is the all the specifications, annual journey distance formula, journey cost calculation formula. And this is for the two-wheelers, three-wheelers and car. You can see that how much money can be saved by switching to electric vehicles from the normal ICE. And government is a major force why people are going for electric vehicles, because they have given so many incentives. And in budget 2020, they have increased the FAME 2 schemes also regarding GST as well as for the incentive, demand incentive. Next, we are going for, these are all the factors which influence the electric vehicles, that are the market dynamics. Next, we go for SWOT analysis. That is nothing but finding out the strengths, weakness, opportunities, and threats of any industry or any market. So this is a strength. Strength is nothing but the pollution. Of course, India is projected to huge pollution, and this is one of the strengths why people, if they switch to electric vehicles, then it will reduce the noise pollution and will be eco-friendly. And India will not need to import. India will not depend on other countries for importing crude oil. And EV does not have a complex engine like IC. It has a simple mechanism. Weakness is the charging time. It will take a lot of time to charge, and the charging facilities, the charging stations, and for the electricity demand will be higher compared to what it is right now. And EV are effective for the short distance, but you go for a longer distance for more kilometers, then you need a charging stations to charge the vehicle. And these are the opportunities. Government of India are providing various opportunities to encourage the employees to switch to electric vehicles market and to produce more of electric vehicles related products. And many foreign investors like Okinawa come to support. So there are foreign investing also, and increase in fuel cost. Since, as I told, petrol and diesel comes from the crude oil, which India has been India is having that a connection with the other countries in order to get the crude oil. They will increase the price, and now petrol rate, you all know how the rate is going on. So due to that, that is also an opportunity. Threat is like EV has a competition from the hybrid fuels, as well as I told, the cost of electricity will depend based on the electricity charge used. And this is the conclusion. Though there are defects in electric vehicles, but that is a greater initiative. There are greater initiative taken by the government in order to promote more electric vehicles for securing the country and for the economical conditions also. And these are the references used. Thank you.
Any questions? Okay.
Thank you, sir.
Okay, thank you. Then we are going to the next presentation. Presentation number is C24. Ishita Sarkar. Ishita, are you ready?
Yes, sir.
Are you ready?
Yes, sir.
Please check your audio and video and try to share your screen.
Is my screen visible?
Yes.
Good morning, one and all. Myself, Ishita Sarkar, and I am a research scholar working under the guidance of Dr. Manjunath N. Today, my topic of presentation is second hyper-Zagreb indices of products related to triangle parallel graphs. This is the outline of my presentation. Abstract, wherein we explore combinatorial inequalities associated with the edges, vertices, and its corresponding neighborhood notions, along with the inclusion of other molecular descriptors in the computations for the determination of exact expressions of second hyper-Zagreb index for certain corona products involving the triangle parallel graph. Further, in order to understand the study better, we have also included the graphical illustrations of the indices of the specified product variants for the path and the cycle graphs. Introduction. Mathematics, chemistry, and information science can be merged, dealing with quantitative structure-property relationship, which serves as a valuable tool in chemical and pharmaceutical field as it aids in predicting the physicochemical molecular properties. Chemical graph theory is a wider domain of research in the field of graph theory, wherein we model the structural molecular attributes. Also, topological index is the basic unit element which we have taken in our study. What is actually topology? Topology is the study of the connectivity of space. So the topology of a molecule, which is represented by a molecular graph, is a non-numerical mathematical object. In order to link but various measurable properties of molecules are expressed in the form of some numbers. So in order to link the molecular topology with the real molecular property, we need to convert the information which is contained in the molecular graph to a numerical value, which is when we require a topological index. Last 30 years, there has been a drastic development in the realm of chemical graph theory, especially in areas related to topological indices. certain definitions which we require in our study. In chemical graph theory, we deal with molecules. Molecules are represented by a molecular graph. Now there are atoms in the molecules. Those atoms represent the vertices or the nodes in the graph, and the atomic bonds joining the atoms together, they are represented by the edges or the links joining the corresponding pair of vertices. There are certain classifications of topological indices as in distance-based, degree-based, neighborhood-based, and interconnected topological indices. The preliminaries for a molecular graph contains of the vertex set and the edge set, wherein the number of vertices and the number of edges are denoted by P and Q respectively. Also, the number of edges which are incident on a particular vertex is denoted by D of W, which is the degree of the particular vertex. The edge of a vertex is denoted by E is equals to VW, where it joins the corresponding vertices V with the vertex W. Wiener index is a classic example among the distance-based topological descriptor. With the introduction of this index, actually bridged off the gap between chemistry and graph theory, linking them together. It is well known for modeling the physical properties of the alkanes. Since then, a vast array of molecular descriptors have come into prominence and significant progress has been made in the discovery of topological network indices. The formulations, while in the study of the Zagreb mathematical chemistry group, two terms appeared in the formulations, which while calculating the pi electron energy of the conjugated molecules. These two terms led to the introduction of the first and the second Zagreb indices. Also, in a paper by G.H. Sherdel, the study on the first hyper-Zagreb index was initiated and certain results relevant to the mathematical techniques of graph operations were obtained. The equation for the first hyper-Zagreb index is shown in equation 1. Also, another topological descriptor, the second hyper-Zagreb index, which is the main element of our study, was initiated in a paper by M.R. Farahani and others, and computations of the related invariant have also been established. The equation has been given as in equation 2. The triangle parallel graph is actually the graph which contains the edges of the original graph as well as the edges of the subdivision graph. For example, we have shown the triangle parallel graph of path graph T4 as in the figure. Also, 4 new graph operational series related to the triangle parallel graphs have been initiated by G. Lan and Bozau. So these are the 4 graph operational series which we have taken. The corona product variants. First, we talk about the R vertex corona product. So suppose we take up 2 arbitrary graphs G1 and G2 with PGI and QGI denoting the number of vertices and the number of edges in the corresponding graphs. So the R vertex corona product indicated as the given notation is obtained by taking 1 copy of our triangle parallel graph of G1 and PGI 1 copies of the second graph, which is a G2 graph, and joining a vertex of the G1 graph on the ith position in triangle parallel graph of G1 to every vertex in the ith copy of the second graph, our G2 graph. Similarly, for our edge corona product, we are concerned with the vertices of IG1. IG1 is nothing but the vertices which are present in the first graph, but present in the triangle parallel graph, but are absent in the vertex set of the original graph. Also, we have included certain neighborhood versions of the corona product variants, the R vertex neighborhood corona product and R edge neighborhood corona product. As for example, we have shown the product variants for 2 graphs. We have taken 2 path graphs, P4 and P2, but the results which we have obtained is true for any arbitrary graphs. So these are the main results where we have obtained the exact expression of the second hyper-Zagreb index of the R vertex corona product of any 2 arbitrary graphs. We have utilized the principle of the degree behavior of the nodes in the resulting graph related to the degree of the vertices which is present in the original graph. This is our result with respect to the R edge corona product. Similarly, for R vertex neighborhood corona product, the exact expression of second hyper-Zagreb index is obtained. For R edge neighborhood corona product also, we have obtained the exact expression of second hyper-Zagreb index. These corollaries have been derived from the theorems wherein we have worked for the standard appealing graphs like path graphs and cycle graphs and obtained the results for the same. The first corollary is for the R vertex corona product. Second one is for R edge corona product. Third one is for R vertex neighborhood corona product. And the last corollary stands for R edge neighborhood corona product. Also, to understand our study better, we have included a graphical depiction of the second hyper-Zagreb index of the triangle parallel graph related corona products for path graphs. From the figure, we have an observation that for increasing values of M and N, the R vertex neighborhood corona product attains the maximum value among the index values of the other graph product variants. Also, for cycle graphs, we have the graphical analysis, wherein similarly the R vertex neighborhood corona product attains the maximum value than the other index values. Also, a small observation from both the graphs is that the nature of the R vertex corona product and R edge corona product for the second hyperzactive index is very close to each other, and with the R edge corona product attaining the minimum value among the index values of the other graph product variants. Certain applications of our study, we can use graph related operations in image and signal processing. Suppose we the signal travel through some signal points or the hubs. These points can be considered as the vertices, and the interlinks of interconnections between those signal points or the hubs can be related by the edges. So we can actually show the entire process of signal in a graph. Also, image processing, the conversion of a 2D image into a 3D image is also very helpful with the help of graph theory. Statistical methods, we use the linear regression analysis, which is a very sophisticated method of mathematical statistics in order to understand that the topological indices which we have taken in our study, how well it is correlated with the characteristics of the traits of the network structures. The complex network structures, here we have seen that we start with some two simple graphs, and what we get as a result of the graph operation is something which is complex network structure. So it helps us in producing infinitely many pairs of co-spectral graphs, that is the graphs sharing the similar spectral properties. Also in data analytics, corona product variance is of immense importance in data analytics, because there we have huge chunks of raw data which we need to analyze in a certain time to arrive at a certain decision. So corona product variance can be of immense importance in that domain also. The conclusion, some specific precise formulations for the second hyperzactive index of certain varieties of corona product related to the triangle parallel graph, particularly the R vertex, R edge, R vertex neighborhood, and R edge neighborhood corona product, variants of two graphs are investigated and explored. Further, our outcomes have been utilized to determine the second hyperzactive index of some standard appealing molecular graphs. The results have beneficial perspectives towards extensive analysis of degree and distance dependent descriptors and series of graph operational procedures. These are the references which I've referred. Thank you.
Thank you. Any queries or doubts from the audience? Okay, then move to the next presentation by Archana V. The presentation number is C25. Archana, are you ready?
Yes, sir. I'm ready with the presentation. Just
Okay.
give me a second to share with.
Check your audio and video.
So, am I audible?
Yes. Please share your screen.
Yes, sir.
Okay, your time starts now.
So, am I audible now?
Yes.
The screen is visible.
Screen is visible, but you are not sharing the exact presentation.
So, PPT is visible now.
Yeah.
Okay, sir. I will see. Good morning, everyone. This is Archana Chapter. I would like to present my presentation now. My topic is a survey of topological data analysis, which is based on image segmentation. First of all, what is exactly the topology? Topological ideas are present in almost all areas of topology in mathematics. The subject of topology itself consists of the several different branches such as point set topology, algebraic topology, and differential topology, which already related to little in common. Topology studies properties of space that are invariant under any continuous deformation. It is sometimes called rubber sheet geometry because the object can be stretched and contract like a rubber but cannot be broken. For example, a square can be deformed into a circle without break it, but a figure 8 cannot. Hence, a square is topological equivalent to a circle but different from a figure 8. So these are some diagrams which is presented here. Shapes of a square, circle, and infinity symbols. Here are some examples of typical questions in topology. How many holes are there in an object? How can you define the holes in torus or a sphere? What is the boundary of an object? Is a space connected? Does every continuous functions from the space to itself have a fixed point? So these are some common questions. Now, topology exactly is concerned with the properties of a geometric object that are preserved under continuous deformation, crumpling, and that is without closing holes, opening holes, or tearing, gluing it, or passing through itself are the subjects of a topology in mathematics. So this is about the topology. Now, what exactly the topological data analysis? The topological data analysis is topological based data analysis, which is a method for analyzing data set in applied mathematics that draws on topological concept. It can be difficult to extract the information from the data set that are high in dimensional, incomplete, and noisy. To identify, to extract, and utilizing their underlying structure has evolved into a problem of a basic importance for data analysis and statistical learning. Due to recent diversity and dimensionality of available data, topological data analysis is a new and quickly expanding field that offers a collection of innovation, topology, geometric techniques, infer aspects for potential complex data. It suggests a new, well-supported mathematical theories and computation tools that can be applied alone or in conjunction with other method of statistical learning and data analysis. So this is about the topology data analysis. Now, the introduction of image segmentation. What exactly the image segmentation is? The purpose of image segmentation is to partition an image into a meaningful region with respect to a partition. The segmentation is based on measurements taken from the image, typical level, color, texture, emotion. Usually, the image segmentation is an initial and vital steps in a series of processes that aims at overall image understanding. So this is about the image segmentation. There are many applications of image segmentations, which includes identifying objects in a scene for the object-based measures such as size and shape, to identify the object in a moving scene for object-based video compressions, to identify the objects which are at a different distance from a sensor by using depth measurement from a large range finder, enabling path planning, or a mobile robot. To find out the image segmentation is the most challenging and fundamental task in a computer vision or analyzing medical images. Amongst the several medical image segmentation methods available in the literature, The persistent homology based methods are relatively new and have several good features with many applications in a image segmentation, that is medical imaging. Persistent homology is a rapidly growing technique from the topological data analysis. That TDA is decade-old field built on the tools from the algebraic topology, which is a branch of pure mathematics, which studies the shape of data. TDA is rapidly growing due to its unique way of analyzing, inferring, exploring complex data sets. In a persistent homology is a method that images are converted to point cloud, then simplicial complex, and constructed at a different varying scales on the top of the point cloud using the filtration process. So several topological features like connected component, loops, or holes are obtained during the image segmentation process. The filtration process at different scales, the image is segmented based on these features. So this review is devoted to the persistent homology, which is based on a medical segmentation. All the methods are systematically reviewed. In addition, the persistent homology with deep learning segmentation, these techniques is also used in this discussion. Now there are different types of image segmentation. So we know the different approaches and the kinds of techniques for the image segmentation. We can start discussing the specific, that is the following are the primary type of image segmentation techniques which is used generally. The first one is a threshold segmentation, next age-based segmentation, region-based segmentations, watershed segmentations, and clustering-based segmentation, which is algorithm to use the segment the image, and the basic neural network for the segmentations. The findings and conclusion for the survey of this paper is the image segmentation is certainly a complicated and advanced topic. All the various image segmentation techniques we discussed in this article have specific advantage and the limitations. By getting familiar with them, we will understand, or we will get the idea of where we should use one and where we should avoid the another. So with all the learned skills, we can get active on other competitive platform as well as to test your skills and get an even more hands on it. So these about the conclusions. Acknowledgement. I thank to my guide. I am thankful to Rajagiri College to give me the chance to present the research paper. And finally, I thankful to my guide also, Dr. Prabha Rastogi, and my friend, Mr. Mangal Sonone, sir. These are some references which is used in the paper. Thank you.
Thank you. Any queries from the audience part? Okay.
Thank you, sir.
Okay, thank you. Then we are going to the next presentation, CP41. Abraham. CP41, Abraham. Sir, please unmute. Please check your audio and video. So your screen is sharing but not audible. Hello, sir. Not audible. Abraham, sir, it's not audible. The screen is sharing. Please say once again. And stop screen sharing and try once again. Hello. Hi, sir. Audible.
Okay, sir.
Sir, please share. Okay, then you can start.
Okay, myself, Abraham Jacob, research scholar RSET, guided by Ramkumar PB, Professor RSET. Contents: abstract and preliminaries, dilation and erosion of induction fuzzy graph, induction fuzzy graph analysis. We have three methods: then application, then conclusion, then reference. In abstract, the study focuses on some properties of mathematical morphology operators on induction fuzzy graph. Morphological operators like dilation and erosion and its composition are useful in the application of induction fuzzy graph. It is essential to study the topological properties using topological data analysis with the help of barcodes and Betti numbers obtained by constructing minimal spanning trees, which extract topological properties of the indulgency fuzzy graph. Finally, an algorithm for analyzing spread of disease is presented in this study. Preliminaries. Mathematical morphology. The main idea behind mathematical morphology is to study geometric structures of an image by probing or matching it with the tiny patterns, named structuring elements at different locations of the image, so that extraction of different parts of the image and their interrelations. Non-linearity of the mathematical morphology, dilation and erosion makes them suitable for the study of geometric and topological structure of an image. At the initial stage, mathematical morphology was used to study binary images using set theory. Then Ronse in 1990 developed a mathematical morphology using complete lattice structure. So using this, any operator alpha from PE to PE defined on lattice is called dilation if it is extensive, increasing, and distributive over supremum. And in the case of erosion, an operator alpha is an anti-extensive, increasing, and distributive over infimum. And also in the case of closing, so alpha is closing if it is extensive, increasing, and idempotent. Idempotent means alpha square, the square of the operator is equal to that operator itself. So any operator defined on lattice is called opening if it is anti-extensive, increasing, and idempotent. Then we can define indulgency fuzzy graph. So when you consider the graph, an indulgency fuzzy graph is of the form G1, G2, mu1, gamma 1, mu2, gamma 2, where G1 is the set of all vertices V1, V2, etc. Vn, where mu1 it is defined from G1 to 0, 1, and gamma from G1 to 0, 1. There is a membership function, non-membership function of the element V or the vertex Vi belongs to G1. When you consider the vertex V1, the sum of the membership function, non-membership function will be in between 0 and 1. And in the case of edge also, the membership function, sum of the membership function and the non-membership function will be in between 0 and 1. And in the case of membership, then the next one is topological data analysis. Topological data analysis focuses on analyzing shapes and topological structures of the data set by which one can extract information. And with the help of theories of algebraic topology and persistent homology, it is good enough to change the data set into simulation complexes and encode this into barcodes and named by Betti numbers. So when you consider the Betti numbers, the points, line segment, triangle, and tetrahedron are termed as simulation complexes. In the case of zero-dimensional simulation complexes, V0 is the number of connected components. So and V1 is the number of holes, and V2 is the number of cavities. Then barcodes. Using these barcodes, we can filter out the short bars as topological noise, and the long bars are persistent topological features. Now we can define the dilation and erosion of indulgency fuzzy graph. So when you consider indulgency fuzzy graph, when you consider the vertex V1, you take the supremum of vertex V1. So the supremum of the membership functions of the adjacent vertices, that will give you the membership function of dilation of the vertex V1. And when you take the infimum, you will get the non-membership function of the vertex V1 in the dilated graph. And in the case of erosion, first you take the infimum for membership function and supremum for non-membership function. Then next one is indulgency fuzzy analysis. So here the undirected indulgency fuzzy graph can be converted into directed graph by defining source and target vertices. Let mu and g be the threshold values of the membership function. Then the vertices having membership function degree less than or equal to mu and greater than gamma is defined as a source, and all vertices of vertices having membership function greater
ये
than
कुछ और कह रहे हैं ना, ये कह रहे हैं खिचड़ी नहीं बनेगी.
gamma we defined as the target vertices. Then we have three methods. First method is the procedure for the first method. Then next one is we have the we can use barcodes. We can use we will get this barcode. Then method number two, we will get we have some procedure. Here we use opening. Then you find out the directed inductive fuzzy graph, and then minimum spanning tree. Then you find out the bar diagram. Then next one is third method using Betty numbers. Then we have application. So we have an algorithm for spread rate of coronavirus. Then conclusion, in this paper we define mathematical morphology operators, dilation and erosion on inductive fuzzy graph. We define directed inductive fuzzy graph from inductive fuzzy graph, and two methods to get directed inductive fuzzy graph. And we extracted topological properties of inductive fuzzy graph using TDA with the help of Betty numbers and barcodes. And these are the references. And thank you.
Any questions? Okay, thank you everyone.
Okay, sir. Thank you.
That was the last paper in the contributory session. The next is the invited talk that will start at sharp 10 a.m. by Answer. Please stay on. Thank you.
Definition of